Hi, we're going to have a look at one of the problems that I see a lot, or it kind of pops up a lot, and it has to do with one of the problems coming from your homework set. And one of the examples that I'd like to go over that looks at how to find z-values, because I think sometimes that might be a little confusing, and then it requires you to then look at a sample as well. So the question is, the ages of commercial aircraft are normally distributed with a mean of 13 years and a standard deviation of 7.8407 years. What percentage of individual aircraft have ages between 11 and 17 years? So I'm going to slide this over here. The first thing is, as soon as you're told something is normally distributed, the first thing you want to do is create a normal curve and just draw like a simple little graph there. You know that the mean is 13. So that's your middle number, and each standard deviation is about 7.8407. So the goal now is you're looking at, so 13 is here. You're looking at ages between 11. So let me just draw this bottom axis here. You're looking between 11 and 17. Okay, so you're wanting to locate the area in between 11 and 17. And so let me just put the numbers up here because it might get confused down there. So 11 and 17. So what we need to do first is find some z-values. So I'm going to go ahead and quickly write those out. Okay, so what I've done here is I've just written down the z-scores for this problem here. So the first one that we're going to look at is the z-score here for 11. So when you're finding the z-score, here's your little formula here. You take, if you want it for the number 11, you put the number 11, you subtract the mean, and you divide by the standard deviation. So I have 11. I subtract my mean of 13. I divide by the standard deviation of 7.84. And my answer is negative 0.225. It's negative because it's on the left side of my mean. Over here, I have the z-score of 17. So I have 17, take away my mean of 13, divided by my standard deviation of 7.8407. And when I do that, I get my answer of 0.5101. Now, I need to look these values up in the z-score table. So the first one I'm going to look up is negative 0.255. Okay, I'm going to have a look here. Here's my z-score table that I just grabbed from online. And I'm looking for my z-score, and I go down, 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 down to negative 2, 0.0, 0.1, 0.2, 0.3, 0.4, 0.5, and then it would kind of be in between these ones here because it's you could round it to 0.39, but I'm going to grab this 0.4013 and oops, I'm sorry, I grabbed the 0.4052, thank you. And then this one here is positive over here. Notice that it's on the other side of my mean, and so my z-score will be positive. So I'm going to use the positive z-score table down here. That will give me, see these, this area over here. And wait a minute, I forgot what it was, 0.51. So I'm going to go down to 0.5. Where am I? There I am. 0.5, and then I'm going to go to 0.1. 0.01, pardon me, which is 0.6950. And that's it right there. So these two values here, this value here and this value here, are basically areas. And I'm going to go to the next slide and just show you how that works. Okay, so what this means is For my z-score of 11 here, it correlates to, from that table, it correlates to a percentage of 0.4052. When we multiply that by 100, my percentage is 40.52%. That means 40.52% of data is less than 11. Okay? And then over here, my z-score correlated to a decimal of 0.6950, which is the percentage of 69.5%. So that means that 69.5% of my data is less than 17. Okay, so we want to find this area in between 11 and 17. Do you see this area in between here? So if I want to find that area, all we do is subtract the 69.5 and the 40.52 percentages, and we get approximately, my area is approximately 29, I'm rounding, 29%. Okay, so that would be the percentage of aircraft between 11 and 17. So I'm just going to pull up my the original question. What percentage of individual aircraft have ages between 11 and 17 years? So we figured out that ages less than 11 is 40.52%. Ages less than 17, there's about 70% of aircraft are less than 17 years of age. So if we want to find the age between 11 and 17, we subtract about 29% of aircraft have ages between 11 and 17 years of age. Now there's a second question here I'm going to pull to the middle. Assume that a random sample of 81 aircraft. Now we're looking at a sample from the normal distribution. It is selected and the mean age of the sample is computed. What percentage of sample means have ages between 11 and 17? So now we're going to look at the sample and the sample mean, and it's a simple little trick. Let me pull up a new page. Okay, so in order to complete this problem, you just need to use the central limit theorem, and the central limit theorem kind of talks about when you have a sample, you need to find this, the standard deviation of your sample. And when you do that, you take your standard deviation from the original problem and you divide it by the square root of the number in your sample. So in our case, if we want to find the new standard deviation for our sample, we'll take the 7.8407 and we're going to divide that by the square root of 81, and then we are left with, let me just do that quickly, 7.8407 divided by the square root of 81, which is 9. I have 0.8712. So now what you're looking at, you have a new standard deviation. You still are using ages 11 and 17. And you're going to do the same problem again. It's just with a different standard deviation. Also, just quickly a reminder from the central limit theorem, it says that for large values, the sample mean will be the same. So we're going to keep our same mean of 13. So I'm going to quickly do these out here. Through 11, take away 13. We're going to find our z-score for 11, and we're going to find our z-score for 17. Our new standard deviation is 0.8712. And our z-score for 17 will be the same here. We got a 17 take away 13 divided by a 0.8712, and we're going to look for our two percentages. Okay, so we're going to look these values up in our chart here. 1 second. Okay, so negative 3.9220, we're going to go back up here. Negative 3.9, negative 3.9 is all the way over here. Pardon me, it's negative, yeah, negative 3.9220. So negative 3, and we're going to go all the way over here. Friends, I had a little error and I was trying to figure out what I was doing wrong. This number is not right. So let me get rid of this one here. Apparently I can't divide. So I'm going to just give you the correct answer. Negative 2.295. 7. So it's approximately negative 2.3. So let's look that up in our chart here. Negative 2.30. So it's something like this, 0.10. So that's saying at 11, so our mean was 13. Let me see if I can put that back in the middle. Our mean was 13. So it's basically saying less than 1%. Super small value. Our age is 11. Aircraft age is 11 from our sample. It's less than 1.07%. Very small value. Now, if we look at the other, for 17, so we're looking at 17 ages, 17 and less. Our number is 4.5914. Now, look at this. If we go to 4.59, do you see how it's off the charts? So if it's off the charts, it goes 90.9997, 0.9998. It means that we're up in the 100%. Okay, so if you're off the charts, you're going to assume that it's 100%. So I'm going to put it over here at 17, and we're going to assume that 100% of the ages are less than 17, so we're going to put 100. And so to find our final answer, you're going to take 100 and you're going to subtract 1.07, and your final answer is about 98.9%, depending, it's really close in there, 98.7, 98.9%, something like that.